Good afternoon, and welcome to the 8th meeting of the Communications Security, Reliability, and Interoperability Council 8, which I formally declare to be open. Thank you all for being here today for our final meeting. Let's get through administrative items first. For those on Teams, I ask that everyone turn off their cameras and their microphone unless you are speaking. If you do wish to speak, please use the hand function on Teams, and you will be called on. For those in the room, when it is your turn to present, or if you wish to speak, turn your tent card vertical. When you're called on, the microphones on the table are equipped with 2 buttons. The one on the right turns on the mic. It will be red when it's on, meaning hot. And for those giving presentations, please say next so Kurian knows you're ready for the next slide. Today, you will be presented with a discussion and a vote on 3 reports. The report on best practices to mitigate vulnerabilities in HTTP2 by Working Group 1 co-chairs Brian Daly and Travis Russell. A report on recommendations on the role of the FCC in promoting the availability of standards for more secure, reliable 5G environment through the use of virtualization technology by Working Group 3 co-chairs Michaela Gihut and John Rose. And the third, a report on recommended best practices to improve supply chain security of infrastructure and network management systems by Working Group 5 co-chairs Todd Gibson and Padma Sudderson. I now turn the meeting over to our CSRIC 8. I now turn the meeting over to Deb Jordan, the Public Safety Homeland Security Bureau Chief. Deb?
Thank you, Suzanne, and good afternoon, everyone. I'd like to begin by thanking CSRIC 8 co-chairs Nazrin Rizai of Verizon and Billy Bob Braun of CISA. Over the past 2 years, they have done an outstanding job leading CSRIC 8, as it has taken on issues necessary to promote secure and reliable 5G networks and to make public safety and emergency services more reliable for all Americans. As I said 2 years ago, this is really important stuff. As you know, the bulk of CSRIC's work takes place in the subcommittees known as working groups. CSRIC 8 has been fortunate to have a remarkably strong slate of working group chairs that include the following. Co-chairs Brian Daly of AT&T and Travis Russell of Oracle, who steered Working Group 1 addressing 5G signaling protocol security. Co-chairs Mike Barnes of Mavenir and George Woodward of the Rural Wireless Association, who managed Working Group 2 as it tackled promoting security, reliability, and interoperability of open radio access network equipment. Co-chairs Michaela Gihut of Microsoft and John Rose of Dell, who oversaw Working Group 3 as it focused on leveraging virtualization technology to promote secure, reliable 5G networks. And co-chairs Mary Boyd of Intrado and Mark Reddish of APCO, who directed the activities of Working Group 4 in examination of 911 service over Wi-Fi. For Working Group 5 on managing software and cloud services, supply chain security, or communications infrastructure, we were fortunate to have Ritwak Jana of VMware as chair to guide commencement of the work, and co-chairs Padma Sudderson of VMware and Todd Gibson of T-Mobile, who seamlessly stepped in to lead the working groups to the finish. And finally, Working Group 6 co-chairs Farrokh Khatibi of Qualcomm and Francisco Sanchez of the Small Business Administration, who skillfully directed the work of leveraging mobile device applications and firmware to enhance wireless emergency alerts. Each of these working group chairs and the entirety of the working group membership applied their impressive expertise and experience to advise the Commission on some of the most progressive ideas and challenging issues confronting telecommunications today. With the conclusion of today's meeting, CSRIC 8 will have provided to the Commission 10 reports in total, 7 of which address 5G network security issues. Specifically, these reports address security vulnerabilities in HTTP2, best practices to mitigate vulnerabilities in HTTP2, challenges to the development of O-RAN technology and recommendations on how to overcome them, how virtualization technologies can be used to promote 5G security and reliability, recommendations on the role of the FCC in promoting the availability of standards for a more secure, reliable 5G environment through the use of virtualization technology, recommended best practices to improve communications, supply chain security, and last but not least, recommended best practices to improve supply chain security of infrastructure and network management systems. In addition, you've produced 3 reports that address important public safety issues: WIA performance reporting, 911 service over Wi-Fi, and WIA application programming interface. This has been a substantial body of work for which you are to be commended. The chairwoman asked you with all the critical, and she sends her thanks today. I want to express the Commission's gratitude for your voluntary service to CSRIC VIII. We deeply value your time and effort, and we look forward to putting your work to good use as we move forward into the future of secure and reliable 5G. Thank you. I now turn the meeting over to our highly capable co-chairs. Nazra?
As this is my final CSRIC VIII meeting as co-chair, my remarks this afternoon would be a bit longer than usual. First, thank you to my co-chair, Billy Bob Brown Jr. of CISA. Our federal executive branch agencies are our primary government partners at the front line of today's security threats and challenges. The Commission's decision to include CISA as a direct participation at this CSRIC speaks highly of its commitment to fostering interagency collaboration and coordination. For that reason, I hope that CISA remains a fixture at future CSRICs. Thank you also to all the CSRIC members, particularly the working group chairs and co-chairs who kept the trains running on time and created excellent reports and recommendations. For each of us, participation in the CSRIC takes us out of our comfort zone and forces us to engage with other stakeholders. Understanding one another's perspective results in a better work product for the public. And thank you to the Public Safety and Homeland Security Bureau staff, in particular our designated federal officers Suzanne Cameron and Kurian Jacob, as well as the working group liaison from Bureau staff for your guidance and support. Finally, a few observations about the value that CSRIC brings to the public. Communications networks are complex. So are the threats facing our industry. Technology and business practices have to evolve quickly to keep ahead of bad actors while also meeting the needs and demands of consumers, businesses in our highly competitive marketplace. The CSRIC enables us to speak candidly with other stakeholders about these threats and challenges and to achieve common objectives. Through that collaboration, we can establish guideposts and objectives that benefit the public interest while also enabling us to respond quickly to security challenges and threats. Thank you, and looking forward to today's presentations. Sure. With that, I will take roll call. Brandon Abley.
Present.
Rob Alderfer.
Present.
Colleen Andrews.
Present.
Mark Annis.
Present.
Mike Barnes.
Present.
Michael Bergman.
Present.
Donna Murphy. Donna Murphy in Marsat. Come back. Shirley Bloomfield. Billy Bob. Wade Buckner.
Present.
Brian Daly.
Present.
Marla Dowell. Andrew Drodz.
Present.
Catherine Elkins.
Brian Tegmeyer, alternate.
Harold Feld.
Present.
Craig Fougat.
Here.
Michaela Guhart,
Present.
Martin Goldberg, Ben Goldsmith, Dana Golub,
Peter Scott, alternate.
Stephen Hayes,
Present.
Craig Hoden,
Present.
Antoine Johnson, Everett Kanashi,
Present.
Javed Khan, Jason is here, Jason Livingood,
Present.
Jennifer Manor, Timothy May,
Present.
Maureen McLaughlin,
Brandon Hinton, alternate.
alternate. Is that what it was?
I think so. Could you speak a little louder, please?
Yes. Sorry, Brandon Hinton, alternate.
Thank you.
Danny McPherson,
Alternate, Young Kim, present.
William McCookie,
Present.
Susan Miller, Derek Peterson,
Present.
Mark Reddish,
Present.
Travis Reuter,
Present.
Nasrin Razai, present. Santiago Rodriguez,
Present.
John Rose, present.
Present.
Travis Russell, Francisco Sanchez Jr., Tom Sabanobori,
Present.
Nathaniel Schroeder, Tim Schramm,
Present.
Sean Scott,
Present.
Padma Sudarsan,
Present.
Peter Tomstack,
Present.
Steve Watkins,
Present.
Cicely Wolf, George Woodward,
Present.
Henry Young,
Present.
Timothy Youngblood.
Drew Moore, an alternate.
Okay, I'm gonna call out the ones that didn't respond.
We have enough, though.
Is that okay?
We have quorum. You don't-
We have quorum.
All right. Since we have quorum, let's go ahead and start. We'll first be hearing from Brian Daly and Travis Russell on the report on best practices to mitigate vulnerabilities in HTTP2.
Thank you very much. If we could have the slides, please. Thank you. And on behalf of Travis Russell and myself, Brian Daly of AT&T, we would like to present the report on the 5G signaling protocol security. So move to the next slide, please. Just a refresher on the background. We were asked to examine and address security vulnerabilities associated with the newly adopted 5G signaling protocol HTTP2. We will confirm these vulnerabilities, identify others, and provide recommendations back to the to the CSRIC on how to remediate the risks associated with HTTP2 and prevent them from carrying over into future protocols. Next slide, please. So our objectives, again, the commission had learned of 4 main vulnerabilities and attack vectors related to HTTP2. Our goal was to research how these and other vulnerabilities and attack vectors may impact the 5G system. Next slide is just a refresher on our working group members, and I would like to thank each of the members for their participation, contribution, and discussions throughout the entire process. I'm not sure if there's a lag, but we're on the next slide, working group 1 members. Thank you. And of course, we want to also thank our FCC liaison, Ahmad, for his guidance throughout the process. Next slide, we did bring in a number of subject matter experts as alternates into the discussion. The security topic is one where we need the expertise from those that are deeply engaged in security, and thus had the benefit of having these alternates participate and provide their input. Next slide, please. So back in September, we did issue our first report on security vulnerabilities in HTTP2, and this was adopted by the CSRIC. And today we are providing our report on best practices to mitigate vulnerabilities both in HTTP2 and HTTP3, which will be delivered for the CSRIC consideration. Next slide, please. So as an executive summary, 5G is a departure from traditional wireless networks. It's not the next evolution building on 4G, but is a completely new architecture with new technologies embedded within that architecture. It's built using IT and cloud technology, not the traditional telecom technology that we see in previous generations. And as such, the signaling protocol used with 5G is the HTTP, which is used in IT and cloud technologies. The network core uses HTTP2, while some support systems may use HTTP1. And this, has raised concerns because there are known vulnerabilities in the HTTP protocol. Next slide, please. So the FCC tasked this working group to identify any vulnerabilities in those protocols, and that first report did identify those vulnerabilities, and the second report is a report on how to mitigate those vulnerabilities and provide recommendations for both industry and the commission. Next slide. The methodology we chose was to look at the many vulnerabilities in HTTP2 for networks with public access, the internet, and see how these same vulnerabilities do or do not pose a threat in a closed network such as 5G. We took into consideration the fact that the 5G is a closed network as we examined all known vulnerabilities and explored other potential threats. And the report identifies the vulnerabilities that pose a threat to the 5G core rather than looking at all the known vulnerabilities of HTTP when used on the internet. We looked at many industry sources. We took input from the commission as well as presentation from subject matter experts. The next slide lists some of the references and sources we used, including industry specifications, industry white papers, as well as researcher claims. And we're very grateful to all the subject matter experts that presented to the working group, as these inputs were, of course, very valuable to our work. Next slide, please. When we look at HTTP2, this has never been used before in 3GPP-based systems. The industry in the past has relied on proprietary signaling technology, SS7, as well as diameter for 4G signaling. 3GPP specified that HTTP2 or later versions be the signaling protocol of choice for future 3GPP systems. And it was specified for use in the service-based architecture and service-based architecture management systems that are defined in 5G and beyond. GSMA has also specified that HTTP2 be used between networks in order to support roaming. And the use of HTTP2 in other parts of the network, such as eSIM management interfaces. The O-RAN Alliance also specifies HTTP2 for orchestration and management interfaces. Next slide, please. So what is the service-based architecture? In previous generations, 3GPP designed the systems to use point-to-point interfaces between network functions. However, as we move forward in time, the network has become more dynamic. We have more virtualized and more functions that are contained within the core network. And as such, that architecture has become somewhat unmanageable. So in 5G, the 3GPP defined the service-based architecture in one of their technical specifications, but that doesn't require the use of every network function for every mobile session. This is a departure from previous generations of wireless, where when you had a core network defined, every network function had to be was typically used for every network session. This also demonstrates the increase in network functions used by the network, and we'll show that on the next slide. And there is also a service communication proxy that is included that plays a key role in the service-based architecture. So if we do move to the next slide, we can see this is the 3GPP defined service-based architecture. And the protocol specified for use between each network function in this architecture is HTTP2. And that's the lowest version of HTTP allowed to be used in the service-based architecture. And there is no access from the outside internet into the service-based architecture using HTTP. And that is an important point, because it is a closed architecture without those external interfaces. Next slide, please. So the management system within it contains two functions. It has an element manager and a network manager. And there's a reference point identified between those two functions. And the management interfaces were then defined for those reference points. And starting with 5G, the architecture was changed to align with the service-based architecture. If we go to the next slide, please. We see that the service-based management function is contained of two services. It contains of a configuration and a performance, as well as has fault management and new services being added in subsequent releases to the specification. Each 5G network function type has its own set of services to provide flexibility, and also allows suppliers and vendors to provide their own sets of services over their own network functions. Next slide, please. So when we look at the standardization of HTTP, the IETF defines those specifications that were developed for internet users to access and retrieve website information. And there have been 4 iterations of HTTP since its inception in 1991. HTTP2 was released in 2015 and was a major revision and a replacement for HTTP 1.1, and it provides better efficiency and reduces online latency. And there's an IETF RFC 7540 that defines HTTP2. Next slide. And there is still work in progress to evolve HTTP. HTTP3 is continuing work within the IETF. While HTTP2 runs on TCP, it does introduce latency issues with the signaling. And Google has defined an adaptation layer called Quick UDP Internet Connections, or QUIC, that emulates the connection-oriented features of TCP over UDP connection. And UDP is much faster than TCP, but it still uses a best effort to delivery. It's a connectionless method, but QUIC will resolve that issue. HTTP3 and QUIC have not yet been endorsed by 3GPP for use in 3GPP networks, as there is still work to be done by the IETF. But 3GPP continuously profiles the work of IETF and updates 3GPP specifications accordingly. Next slide, please. So in our analysis of HTTP vulnerabilities, we note that version 2 supports a wide range of applications, including the World Wide Web, internet, and specialized services such as microservices. The service-based architecture and management system is one example of such a specialized service. And while it is possible to use these known vulnerabilities researched by the CSRIC against any internet connected entity, the 5G architecture is not connected to the internet and is a closed network. And to gain access to that network would require compromise of the network from within a company's resources. And while possible, it's highly unlikely that such a compromise would be feasible. And the working group does provide recommendations to prevent insider threats in its final report. Next slide, please. So some of the assumptions in our analysis of the vulnerabilities. The first assumption is that the 5G core has deployed robust network perimeter defenses between closed networks around the service-based architecture functions. The second assumption is that these vulnerabilities would be second or subsequent stages in a multi-stage attack. An earlier stage would have to compromise access to the service-based architecture or management system. This means that some of the vulnerabilities that we researched would not be applicable to a 5G network core or have minimal impact. Next slide, please. So our overall recommendations, while the use of HTTP 1.1 may be common outside the 5G core network, the known vulnerabilities associated with 1.1 suggest use of 2.0 or later versions of the standard is recommended for 5G signaling applications. And for use in US deployments, HTTP 2 is strongly recommended for cybersecurity reasons. HTTP 2 does allow an option to implement clear text mode that enables trusted middle boxes to eavesdrop, modify, and inject HTTP requests and responses. This option is not intended to be used for signaling in critical infrastructure like 5G. HTTP 2 encryption is on a per JSON packet basis, providing integrity protection where JSON packets with routing information can be sent with clear text mode, with the payload JSON packets being fully encrypted. HTTP 2 and 5G core networks should use encryption and provide integrity protection. And if and when 3GPP adopts HTTP 3, HTTP 3 mandates encryption and integrity and protection based on TLS 1.3. So consistent use of authentication, encryption, and integrity protection aligns with zero trust principles. Next slide, please. So further, our report assumes and recommends that proper security controls and best practices are in place to mitigate threats that may be internal to an organization, to detect and mitigate risks and compromise to system credentials and unauthorized access. And in terms of operational segmentation, the group also recommends that operational administration systems and controls rely on dedicated consoles and not use generic or general purpose devices such as laptops or PCs to access administrative, and operational systems. Any laptop or PC used to access the internet or email should never be used for accessing the 5G system. And it's also recommended that monitoring and detection of network function deletion actions require proper escalation, review, and approval prior to actual implementation of a deletion request. Given the automated nature of network scaling, this is best accomplished through AI mechanisms that detect multiple network function deletions and can prevent such an activity. Next slide, please. So some of the client attacks on servers. This type of attack is initiated against HTTP2 clients and HTTP2 servers. These include slow read attacks and slow post attacks, HPAC bombs, dependency cycle attacks, stream multiplexing attacks, URL prefix injection, SBA customer attack, and customer header attacks. Next slide, please. So for the slow read attack, this vulnerability was identified by the Commission as an example of vulnerabilities and were included in the tasking for our working group. This is where the attacker sends a valid HTTP request to the server. The attacker reads responses very slowly. This does keep the connection alive without timing out, resulting in the server dedicating resources to the connection. And eventually those resources are overwhelmed and flooded with such requests, blocking other requests from getting through. This attack is not explicitly banned by the IETF RFC 7540. So our recommendation, if we go to the next slide for slow read attacks, the SEP and SCP server implementations and network integrations should consider the server capacity. Upgrading capacity as a stopgap as an aggressive attacker can step up the attack rate and still overwhelm the increased server capacity. Reverse proxy-based protection can potentially intercept some of these attacks, and it can limit the request on a per route basis. There could be timeout rules that could be applied. A connection timeout heuristic can be determined on the statistics of the other connections. Enforcing a minimum data rate and by applying data rate rules, doing pattern analysis to do intrusion detection and prevention using patterns of request that can potentially identify malicious connections, and for non-specific distributed denial of service mitigations, consider segmentation and monitoring. Next slide, please. So the attack can be mitigated by establishing a minimum incoming data rate, ignoring and dropping any connections that have rates slower than minimum, setting up an absolute connection timeout, and rejecting or dropping connections to HTTP methods that are not supported by the server in order to drop post messages which are not expected by the service. Now, SCPs and SEPs cannot say if the target HTTP servers support the specific HTTP methods, and these won't be able to cache this info for each network function producer or consumer for callbacks and notification. The next area we were asked to task was HPAC bombs. RFC 7540 does permit the sender to define the max size of the header compression table, and it does not restrict the size of individual headers. So the attacker can insert a header field that is exactly the size of the HPAC dynamic header table in the dynamic header table. The attacker would then send a request to expand the header field repeatedly, and that attack can quickly result in gigabyte level storage requirements on the target machine. And the end result is a denial of service as the target server's resources are exhausted. Next slide, please. So the recommendations for HPAC bombs, this takes advantage of the server implementation that does not limit unpacked memory in response to requests using HPAC header compression. The mitigation is to set limits, either fixed or dynamic, according to some heuristic. And here, a link here gives an example of one of those heuristics. Next slide, please. The next area we were asked to look at was dependency cycle attacks. RFC 7540 does allow a stream to give an explicit dependency on another stream, and that allows the server to prioritize stream handling. And the dependency graph must be a strict tree. That is, processing a loop or cycle in the graph can cause unpredictable behavior, such as infinite loops. The result, again, is a denial of service attack as the target server's resources are exhausted through these infinite loops. So next slide, the recommendation for dependency cycle attacks. There are two elements to the mitigation. One is to prevent the dependency cycles, and the second is to prevent unlimited graph size. There was an original Imperva research that provides when a client tries to create a larger graph than using priority frames, the server throws away old streams, and the recommendation would be to use that. However, the server implementation should also restrict dependency graphs to a strict tree structure. Next slide, please. We were also tasked to look at stream multiplexing attacks, and an HTTP2 stream requests a single request response cycle. Once the cycle is closed, the specifications require that the stream identifier is not used again over the same connection. And if an implementation of the HTTP protocol stack on a server fails to follow that requirement, the result is going to be a denial of service attack. The working group classified this as an implementation vulnerability, and we've defined it in section 617 of the report. Next slide, please. So the RFC clearly states that for a given connection, stream identifiers cannot be reused. So in this vulnerability, a flawed implementation fails to observe this requirements consistently. The mitigation is therefore for implementations to follow the RFC in this detail. Next slide, please. The URL prefix inject, which is the value of the stream header, is meant to be HTTP or HTTPS, but it supports arbitrary bytes. Some protocols or implementations use it to construct a URL without performing validation, which then allows the attacker to override the path and possibly poison the cache or create a server-side request forgery vulnerability. And while, again, the RFC does allow this, implementations lacking validation to this vulnerability can be effective. And since the 5G specifications are unknown, this was considered as a protocol level vulnerability. And while this may not be an implementation vulnerability, it was included in a report for more thorough review and classification in the next report. So the recommendations for URL prefix injection are to perform validation on all header fields received from the client, but specifically for the arbitrary data in the scheme pseudo header. The server should only accept HTTP or HTTPS or other specified character strings as required. And the extension in TLS is also used for this purpose. However, if the actual scheme is not as expected, then it should be rejected. Next slide, please. The service-based architecture customer attack. So the following sequence illustrates this attack. An attacker compromises or takes control over a session management function and is now inside the SBA. The compromised SMF mounts an SBA denial of service attack against the universal data management using the slow read vulnerability. And the 5G network operations degrade under this attack by the compromised SMF instance. This attack requires earlier steps to compromise the SMF as it's an insider attack. Next slide, please. So the recommendations, as stated previously, and in the context of insider threats, we recommend that the operational administrative systems and controls rely on dedicated consoles and not use generic or general purpose devices to access administrative and operational systems. Again, if your laptop or PC is used to access the internet or email, it should not be used for accessing the 5G architecture. And to reiterate, the group recommends monitoring and detection of network function actions and further require proper escalation, review, and approval prior to actual implementation of functional changes to the network. Next slide, please. So the heist attack, this is based on vulnerabilities in other protocols and implementation shortfalls. And because SSL and TLS does not hide the length of the clear text message, which is a well-known weakness that's been known to the security community since 1996, adversaries can directly infer the length of the response before encryption. And with this information, the attacker can utilize details of other protocols and web browsing activity, including the handling of third-party cookies to extract encryption behavior. More information and its applicability are provided in this final report. Next slide, please. So our recommendations, the 5G core needs to be continuously scanned for port scans of the operating system. A credential scan of the OS may be performed on some network functions depending upon the business requirements, and application layer scan of network functions also be undertaken. Once anomaly is detected, a ticket should be generated for any vulnerabilities found on the scan, and the security operations team should contact the vendor to confirm the vulnerabilities or to make sure there aren't any false positives. If no false positives, start planning to have a timeline to fix the vulnerabilities with the respective vendors, and make sure you have lab testing of patch and point release updates that remedies the OpenScan vulnerabilities. Next slide, please. So the custom headers attack, in addition to the standard HTTP2 headers, 3GPP has defined several custom headers that are specific to the 5G's service-based architecture. Some of these headers are defined for flow control and could be used to compromise a network function to slow down or shut down critical functions within other network functions. And there's a reference document which shows more details of this particular attack. Next slide, please. So the recommendations on the custom headers attack is, again, monitoring of network functions is recommended to determine if a network function is compromised. The mitigation is to ensure that comprehensive monitoring capabilities are in place, which can detect and notify the network operator about abnormal network function behavior, and hence enable the execution of appropriate mitigation countermeasures, such as isolation or remove the network function from live service. Next slide, please. There are a number of implementation vulnerabilities that we analyzed. These don't implicate HTTP2 systems in general, as do those protocol issues, but recommended mitigation for implementation issues is a matter of upgrading to a version of the software provided by the product vendor that has a fix for the issues. When selecting vendors providing network functions to be used in the 5G system, those functions should be tested and validated prior to deploying in the network. All network functions should be compliant with the 3GPP security assurance specifications and its evolution for a specific network function. These vulnerabilities were not considered by Working Group 1, as they are tracked through CVEs and fixed by each individual product supplier through patches and that's really outside the scope of Working Group 1. So next slide in conclusions. While the use of HTTP 1.1 may be allowed for some parts of the 5G ecosystem, the known vulnerabilities suggest the use of HTTP 2 or later should be standardized for all 5G signaling. All service providers providing 5G services or maintaining 5G systems should ensure that they have practiced the latest network hygiene and implemented the latest security best practices to prevent insider threats. For the Commission, if future evolutions of 3GPP standards make a determination to adopt the use of HTTP 3 and QUIC, the Commission should consider future CSRIC efforts to study the use of HTTP 3 and QUIC in the context of 5G and future systems. And again, for the Commission, a future CSRIC should research the security and vulnerabilities of APIs used within 5G networks, both within the core network or exposed outside of the core network. Well, again, with that, I would like to again thank all the members of Working Group 1 and the Commission for this, and we'd like to again present this final report on security vulnerabilities and mitigations in HTTP 2. Thank you very much.
Very good. With that, I'll ask the group for any considerations or questions for Working Group 1. Anyone?
So, question. The heist attack is the only one that appears to potentially involve outside vendors or providers. In terms of once the vulnerability is identified and patched, is there a recommendation with regard to vendor activity to communicate with other network operators, or did that go into implementation vulnerabilities and therefore fall outside of the scope of the working group?
Yes, thanks, Harold. That more or less falls outside of the scope of the working group. I think that goes into some of the processes that are in place in order to communicate vulnerabilities to the industry once those are detected and fixed through the vendor community.
Thank you.
Anyone virtual? Oh, sorry, Michael, please.
Thank you. Hey, Brian, thanks for a great summary of that work. I just wanted to mention one thing in passing. The working group had a habit of, I was on the working group, we had a habit of referring to the first report and second report throughout the project. And in some of the slides, we still have some of the holdover language about this being the first report, and there is a future report. This is the future report. So that's slides 13, 37, and 41. So this is the future report. This is the deliverable.
Yeah, thanks. I caught that. Yeah, but yeah, when we make reference to the future report, it's really this report that we're delivering today. Thank you.
Any questions from folks on the call? All right. So with that, I'd like to ask all in favor of this report, please say yay.
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 Yay. Yay. Yay.
All not in favor of this report, please say nay. All right, the report is accepted. Thank you.
Thank you.
I'd like to pass it on to Working Group 3 to speak to the reports on recommendations on the role of FCC in promoting the availability of standards for more secure, reliable 5G environment through the use of virtualization technology.
Right, John Rose here. I'll begin the conversation. Michaela will close the conversation. She's virtual. First, I want to thank everybody for doing this report. As the previous report on virtualization showed, the FCC's world is getting more complex. It's diversifying, and I think both of these reports and this dialogue actually maybe expose some of the comfort issues of working outside of pure telecom, but the future of the FCC is very likely to be interdisciplinary and multi-domain. So if we jump to the first chart, I'm not sure where the slides are here. Let's see. There we go. Next, next one, I think. Can't really read that. It's be slide 2, actually. Sorry. Slide 2, please. Yeah, there you go. Okay, it's inverted. Just to remind everybody, there were 2 reports. They both covered the intersection of 5G and the virtualization world. The previous report was much more specific to security technology guidance. This report was much more about how to catalyze and encourage the use of virtualization for secure 5G environments. They're related, but slightly different. Next chart. The methodology we used was exactly the same. We bring together a collection of experts. In this one, we had to be quite broad because it touches a lot of the IT and cloud and other areas along with security and telecom core. We tended to pull in outside experts, gather data, distill that data. The first report was much more focused on very specific recommendations related to security and virtualization and expanding that surface area. This report, on the other hand, was focused on 4 questions the FCC had posed to us. You'll see on the chart those 4 questions. We'll talk a bit about them as we go through this, but just to frame it, we were not arbitrarily looking at the virtualization world in 5G. We were addressing these questions. So if you're ever wondering why the recommendations exist, they relate to this. Okay, next chart. The working group itself, first, thanks to the team. We had a very strong working group. I applaud everybody for working in the tail end of the pandemic and getting us back together face-to-face for the first report. And the second was an interesting learning experience, but a great collection of people who signed up from the beginning as primary members. If you jump to the next chart, we also had a number of alternates. I wanted to call out 2 people particularly that helped us. Obviously, Jeff, our FCC liaison, was critical. And then Roland Shaw, who stepped in kind of midstream to be the editor of these reports. We did find having a formal editor role was extremely useful because everybody's busy, and it allowed us to stay on target with respect to content. So that may be a best practice if people don't already use it. Jumping to the next chart. A couple of things before we jump into the recommendations. They're fairly high level, but how we got there and some of the ways that we thought about it. The first was, this is a topic that is very broad, and so our deliberations and thoughts were really looking at industry-wide context, not just telecom context. The second is, this is much like the first report, an area where it's a convergence of different disciplines and ecosystems, and so it is a complex area to work in, but necessary. The third was interesting because the ask was how we can encourage standards and adoption. This area is heavily fragmented, overlapping, and complex with respect to the jurisdictions of various entities within even the U.S. government. And so FCC's role, hopefully will play a role of maybe disentangling some of that complexity and acting as a bit of a North Star. The fourth item was that, obviously this is not a discussion of virtualization in a vacuum. We wanted to apply, the bias of critical infrastructure. These are critical infrastructure. They are not just a virtualized environment. So hopefully that came out. And then finally, obviously the ask was to make recommendations the FCC could act on. So very helpful. Many of our members had a lot of experience looking at the tools that are available to the FCC, because it is not an omnipotent organization with infinite power, but it does have very specific tools that we wanted to target. Okay, next chart. We had a total of 6 recommendations. They're all in the report with a lot more detail. I'll go through them at a high level just to frame them for you. The first was a very specific recommendation to use the Memorandum of Understanding vehicle between departments to improve interagency collaboration, information sharing, and coordination. Because of the diverse set of constituencies involved in this topic, what we discovered is there weren't really formal vehicles in which information was exchanged. There was informal channels and collaboration, but in this particular topic, if FCC is trying to establish policies or frameworks or opinions, formalizing that interaction using MOUs and other tools is valuable as opposed to the informal channels. The second recommendation was that the FCC should enhance collaboration with industry using the FCC TAC and NIST to identify relevant standards bodies and stay informed. The reason for this, and we talked about it in the first report, is these standards underneath virtualized 5G are much bigger than 3GPP. And those standards bodies tend to evolve and morph, and it's incredibly important that if the FCC wishes to establish policy or frameworks in this topic, that they have an accurate view. Now, earlier in the previous report, we did talk about the fact that maybe the FCC isn't the vehicle to create that view, but in the absence of anyone else creating that view, FCC policy has to be based on a comprehensive understanding of all stakeholders contributing to the standardization of a modern virtualized 5G environment. The third is a little bit of a timely thing. Maybe 5 years from now this won't matter, but we did recommend the executive branch agencies in Congress, or the FCC recommend to the executive branch and Congress, that we encourage incentivization for U.S. participation in standards bodies. We also called out, because there was a recent administration policy around encouraging people to participate, that particular statement did not acknowledge the fact that there continues to be an economic disincentive to participate in international standards bodies. Our tax policy does not allow for the use of R&D tax credits for work done outside of the United States. Those are the jobs that you would hire to actually do this work. And so we do believe the FCC, if you're going to weigh in on this topic, which we think we should also look and spend time understanding what the disincentives are and why it is either economically disadvantageous to do it or complex, and we need to remove those. Otherwise, that the administration's focus on encouraging industry to participate will probably under-execute. And so we did include some reference to interest enough, I never thought I'd be talking about tax policy in this thing, but we actually pointed to the relevant tax laws and what is actually occurring. And we do think that's a very actionable item where FCC to weigh in to try to create real incentives as opposed to just encouragement to do work in an area that already has economic disincentives associated with it. All right. Next chart. Number 4 on the list. The FCC can promote innovation in the virtualized 5G ecosystem by establishing means for user groups, vendors, and developers to share requirements, et cetera. This goes to the need for the FCC to exert its convening authority in this area. It is incredibly important in these complex ecosystems that people who are considered neutral and authoritative but open act as convening authorities. It is actually quite hard to find convening authorities for these topics, especially around regulatory outside of industry lobby groups and trade groups, but in government, it's not entirely clear where those convening authorities should be. So our general consensus was, while the FCC may not be a direct participant in a standards body and create standard, it can actually be a vehicle to actually pull together the various stakeholders and create alignment and coordination across the various elements of either government or industry. And again, we should not underestimate the need for convening authorities and the power of convening authorities. And the FCC, in our opinion, has the moral authority to convene the industry, much like CSRIC is. So again, high encouragement of the FCC acting as a convening authority as opposed to a singular participant in these standards activities. Number 5 on the list is to build confidence in the virtualized 5G solutions based on open source cloud computing software. By the way, this was one of the specific questions asked of the 4. The FCC could support a testing and validation framework, foster a culture of collaboration, create incentives for network operators to adopt these solutions. What this really says is, in the absence of technical frameworks. Today, many of our open source technologies, including Open RAN, actually lack implementation frameworks. They describe technology, but not the plug compatibility and the interoperability between them. We don't believe FCC would do that work, but we do believe that that work needs to be done, and the FCC should encourage that it be done. You could imagine a world where, for instance, open architectures are not implementation agnostic, but actually have a point of view about how to properly integrate them, how to test them, how to develop system-level performance characteristics. We do acknowledge that a lot of this is the current dialogue going on out of NTIA and the Wireless Innovation Fund. The first NOFO did actually focus on this area. We would encourage you to pay attention to that. But the bottom line is, we should recognize that just simply the availability of open technology is not a sufficient path to make that open technology work in a telecom environment. And today there is a lack of open telecom integration standards and frameworks, and we believe that FCC could have a voice in encouraging that type of adoption. In fact, in a future world, it may in fact be a requirement, but today we are in the process of figuring out how those implementation standards could exist. Number 6 on the list, the FCC should consider the overall health of the virtualized 5G solutions ecosystem, including diversity, productivity, security, resilience. When making regulatory decisions, industry, government, academia must all participate in this goal. This is a commentary on the maturity of this space. Even though 5G is the first kind of cloud-centric, virtualized, software-defined wireless technology standard from 3GPP, it is by no means a mature ecosystem yet. There, especially around open architectures like Open RAN, we have a relatively nascent industry that's highly fragmented, somewhat immature, and so it is important that the FCC, when making policy, consider and keep awareness of not just that the industry exists, but the current health and state of that industry. Where are the gaps? Where are areas maturing? Where are there strategic or potentially national security issues because we have a gap? Today we have an environment, as we all know, that many of our sources of supply are non-domestic in this space. As we move into the next world, it is incredibly important to try to address that and to understand or at least acknowledge what that supply chain and what the ecosystem looks like. So again, a lot of these recommendations are very much about bringing awareness to the FCC process as we start to move into this much more diverse telecom ecosystem. And most importantly, having the FCC play its role that we think is less about defining the technology, but more about convening the industry to get to good outcomes. And this one is particularly complex because it stretches far beyond the traditional boundaries of the FCC. Turn it over to Michaela to make some concluding comments. But again, before we do that, thank you very much for having us, for running this process, and for the team for doing the work. Michaela, over to you.
Thank you very much, John. And I would like to add my thanks to FCC to allowing me to participate in this experience and the opportunity to work with a great team of people, which enriched my knowledge and my understanding of the critical requirements for the communications networks. With that, if I can see the slides, that will be great. Thank you. I would like to again reiterate some of the things that John said. We have worked quite a bit to figure out how to frame the questions and how best to answer, because this report was a little bit more qualitative rather than quantitative. Again, the previous report was very specific. This one was more about the role of the FCC in this complex, times in which everything comes together from different directions. So in the end, one of the first conclusions we had then, it was sort of an epiphany. We decided that CSRIC actually it's one of the best tools that FCC has put in place to bring together experts from different companies, different public as well as private areas, and figure out what is the best path forward. So again, one of the main conclusions is that continuing CSRIC industry advisory is very advantageous for addressing future multi-domain and multi-disciplinary telecom topics. The second conclusion was again something that John mentioned. FCC, its role, it's not necessarily seen as the one that will decide on a technology as much as the role is to really be the mediator, the convener, or the navigator across this ecosystem, which is absolutely crucial because, again, the telecom industry now has boundary way beyond what previously we have known. And that leads to the third point, which is the telecom problems are not longer exclusive to the industry, and FCC can really play a unique and vital role in the broader ecosystem challenges. And with that, I would like to thank again everybody. Thank you, John, for your partnership. Thank you, Jeff, as well as, again, thank you, Roland, who played a very important role in being our editor. Thank you again for the opportunity.
Thank you. With that, I'd like to open to the group for considerations or questions for Working Group 3. Marla?
Really want to applaud this, the recommendations and the depth to which this group went into this. One thing I want to highlight is that the recommendations that you have in here are consistent with the national standards strategy for critical emerging technologies, and I think it's worth making sure that those are well aligned. This is an opportunity for the FCC to get support from the White House on these recommendations. So the iron is hot, so to speak. The CHIPS for America program faces a similar problem with the complexity of the standards landscape. There are over 5,000 standards bodies for semiconductor manufacturing. So NIST actually undertook an analysis of that landscape and is putting together a report in this space. I'd encourage maybe the FCC to reach out to this group. I could certainly put them in touch with it, rather than reinvent the wheel in terms of trying to figure out what the landscape looks like. And then the last thing is this framework recommendation that you had about the framework for testing and validation. Are there recommendations that this group would make with respect to the Public Wireless Fund and their first initiative to, I have a concern about them establishing all these testing facilities without a consistent way of doing the testing. Oops, sorry.
Yeah, we had a lot of discussion around that because we're all very involved in it. Trying to make this document live longer than 6 months, we tried to make it a little bit more generic, but yeah, specifically, I'm not sure how you decide what to test or even what to build without an implementation framework. It's insufficient to just implement to a standard without some proof of life that when you actually put it into the integrated system, you deliver acceptable performance, scale, and functionality. And so we know that is a very active discussion in NTIA right now. We are not sure if that's the vehicle or if there's another. The good news is there's an active discussion. The point we tried to make is both now and in the future, and I think the now is the important one, FCC may want to weigh in to encourage that to happen and to figure out the right entity to do it. Because without it, it just represents risk is our concern. And long term, 5 years from now, we still need the same thing. It's just today we have an urgency of the starting point. Yeah.
Anybody virtually with questions for Working Group 3? All right, with that, all in favor of the report, I'd like to hear yay.
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 Those not in favor of the report, say nay. All right, the report is formally accepted. Thank you, team. Working Group 3. All right, next, Working Group 5, report on recommended best practices to improve supply chain security of infrastructure and network management system. Please.
All right.
Todd and Padma?
Yes, could you turn on the slides, please? Could you share the slides, please? Or... Yes, thank you. So good afternoon, everyone, and thank you for giving us the opportunity to present the Working Group 5 report today. So my name is Padma Sudarsan, and I'm a co-chair of the CSRIC Working Group 5 along with Todd Gibson. And Todd and I will jointly provide the readout of the report today on best practices to improve supply chain security for the infrastructure and network management system. Next slide, please. As a background, the core objective of the working group was to review the risks to the service providers' operations from the attacks in supply chain and to develop mitigation strategies for these vulnerabilities. And the FCC had also asked the group to recommend best practices to mitigate the risks for each of the vulnerabilities that we identify. So in this readout, I will start off with the introduction, definition, and some analysis that we have done, and then hand it over to Todd to address the key findings, vulnerabilities identified, and the recommendations, including the next steps. Next slide, please. Okay, this slide has the list of the names of the team members that we worked with on this report. First, I want to take this opportunity to thank my co-chair, Todd, for his leadership, his expertise, and for partnering with me in this effort. And we'd also like to thank our liaison, Saswat and Zenji, who have been great partners, and we'd like to thank them for all their guidance. And Todd and I had the honor of working with a lot of very knowledgeable people. We had a diverse representation in the group that included various agencies, standards representation, telecom service providers, software cloud vendors, government groups. It was a very collaborative effort, and we'd like to thank the members for their contributions and their efforts. And we'd also like to recognize the great work Tim May did in a rapporteur role for the working group. As was mentioned in the previous report, this was extremely helpful for us. Next slide, please. And this lists a number of alternates that were identified by the working group, but many of them had actively contributed to the discussion. So thank you. Thanks to the folks on this list as well. Next slide, please. So the supply chain vertical is a very broad topic and includes both software and hardware. Therefore, the supply chain security report had been broken up into two deliverables. The first report was on supply chain security, where primary focus was on the software supply chain security. This was completed and approved September of 2022. The second report focuses on the supply chain security for infrastructure and the network management system. This report is being submitted today for full council consideration, and our readout will mainly be on this report. Next slide, please. So the overall structure, the way we organized the report, we start off with the executive summary, followed with some objectives and the scope, and we include the definition and the methodology we use for addressing the topic. And the group also gathered and analyzed all the industry and governmental efforts, including the representative attacks and the emerging threat vectors. This was so we could get a full picture of the state of the supply chain security. And finally, of course, in chapter 7 and 8, we provide a summary of the key findings and recommendations and some mitigation associated with them, including additional recommendations for the Commission. Next slide, please. So as we started the discussion, the first thing that we wanted to do was, as a group, collectively define the what infrastructure meant and what network management systems meant, and define that scope clearly so that it's consistent with FCC direction. So we actually went back and forth with the folks on FCC to make sure that we got the definition right. So what you see on the screen is really the outcome of that discussion. So the way we defined infrastructure was infrastructure includes software-controlled hardware, such as routers, radios, switches, cloud infrastructure, servers, and managed customers' premise equipment. So the way we define managed CP devices, they're the ones that are managed by the CSPs and or cloud providers. Although unmanaged CPs, things like customer-owned equipment or IoT devices can also harm the network, we did not address the topic in this report. And part of the reason was the National Institute of Standards and Technology has developed a program that focuses on unmanaged and IoT device vulnerabilities. Likewise, physical transport media, such as optical transport, electrical communication cabling, materials used to create these components are out of the scope of this report. Network management systems include applications that enable a CSP to intelligently manage and operate the networks. network segments and the associated network services, and it includes individual devices that are delivering the communication services. These infrastructure, all of these network management systems and the infrastructure are now being deployed in the cloud. So, of course, cloud deployments was in the scope of this report. Even though we had come up with a clear scope and for the second report, while we were analyzing the cyber incidences and cyber attacks related to infrastructure and network management systems, we realized that, the report concludes that the software supply chain security is very relevant and inseparable from the discussions that we had around infrastructure and network management systems. And that is seemed quite understandable because all infrastructure and network management systems contain software that, and therefore the first report we had on the software supply chain security was very relevant to many of the topics that we discussed with the second report. Next slide, please. So beyond the definition of the two domains, the work group also agreed to leverage the ARIS's 5G network assured supply chain lifecycle model that's captured in this diagram. But just to be clear, this is not really, this diagram doesn't, the flow is not intended to convey a sequential step in the supply chain, but rather to illustrate that there's a continuous flow of supply chain functions and processes across the integration and deployment of network infrastructure. And the supply chain lifecycle that is applicable to both hardware as well as software components. And they can be kind of grouped into two distinct phases. One, where a thread can be inserted into a component within the supply chain of an operational system. And the vulnerabilities then, on the second part, would be the vulnerabilities then exploited in the operational environment. And this supply chain threats are present at each of these lifecycle functions. And the paper recommends that we should consider all of these different flows for any supply chain mitigation plan. Next slide, please. So the FCC also directed us to also recommend best practices to mitigate the risk for small communication providers, considering the vulnerability that have affected these providers and their capabilities. So we actually referenced the World Economic Forum Global Security Outlook 2023 Insight Report, which indicates that the entire supply chain ecosystem could be negatively impacted if a smaller organization is taken out of action. Likewise, the report, Verizon report in 2022 on breach investigation report also found that contrary to what many may believe, small organizations are just as vulnerable or as enticing to criminals as large ones. And in certain ways, they may be even more susceptible to these kinds of problems. So, traditionally, the de facto responsibility for navigating these risks of vulnerable technologies has traditionally rested on small businesses or individuals or local governments. But to be effective, an effective cybersecurity requires cooperation and coordination across the many public, private, and international stakeholders in the ecosystem. Next slide, please. So the group also analyzed all the current government and industry efforts so that we can get a baseline of all the activities that are happening in the industry and understand the state of the supply chain security. So we went through a number of these, and I won't go through all of them just in the interest of time, but just to highlight a few. So the executive order on the Americas supply chain was published in February of 2021, which primarily focused on critical materials such as semiconductor batteries, critical minerals, pharmaceuticals, etc. But this one did not include any directives related to software supply chain domain. Likewise, there were a number of CISA reports, one published in April 2021. CISA published a supply chain attack report that introduces guidance on how to defend against such attacks. And there was another one in April 2023 on shifting the balance of cybersecurity risks, and one that talks about cyber performance goals, such as supply chain incident reporting, supply chain vulnerability disclosure, vendor supply, cybersecurity requirements, and so on and so forth. There are also many industry efforts that are taking this head on. So the MITRE supply chain security is, where there's a lot of effort going on in understanding supply chain risks and key to ensuring robust and resilient supply chains, trustworthy partners, and trusted components and systems. There's also the ADIS group that provides necessary requirement necessary to operationalize a set of agreed upon levels of supply chain assurance that can be associated with deployment and operations of 5G networks. The ORAN Alliance, which has a working group 11 that is focused on addressing security requirements for telco deployments, including cloud-based deployments. So all of these have been captured in the report, and there are details available. They're pointed to the appropriate references so that you can get a holistic view of what's going on in the industry. Next slide, please. So while we were talking about supply chain security, especially for infrastructure, we realized platform security is related to the security of the hardware and is the foundation for security capabilities in the product. So since it's critical for both infrastructure and the network management system, we have explicitly called this out in the report. So the main building blocks for platform security are hardware root of trust, secure storage, secure boot, secure debug. Security needs to be built into the hardware platform from the beginning, and security built in the silicon with a chain of trust can go all the way up to the application layer to ensure authorized and digital signed software loaded into the hardware. So these are some of the analysis we have done. Now, I will hand it over to Todd to walk us through some of the supply chain representative attacks, emerging threat vectors that were analyzed, and we'll go through the key findings and recommendations that the group have identified. So over to you, Todd.
Thank you, Padma. Appreciate it. Hello, everyone. Okay. So, as noted previously, we were chartered, and Padma did a great job in identifying that, we were chartered to identify the vulnerabilities and mitigation recommendations around infrastructure and network management systems. Right. First, we had to go through that definition phase, which Padma already talked about, to make sure that from a work group perspective, we're all on the same page. But I think all of us were a little bit surprised when we started doing the research on recent cyber events related to these two topics, on how little information was available online pertaining to these two topics. And so we had to improvise our approach a bit. So what you'll see is that we first list out here some representative attacks, which are attacks that are very much in line with the topic at hand. But then we also created our own emerging threat vectors, which are discussed in the next couple of slides. And those emerging threat vectors are the potential of what we see tomorrow, right? And from a supply chain perspective, and what are those topics that we feel like, or technologies or domains that are very relevant and to the particular discussion at hand that we can build some recommendations off of, later on in the report as well. So for the representative attacks, we looked at how the products were secured by design and by default, which we identified a few, including a recent hardware vulnerability attack, which was initially, which was related to legacy platforms, which was originally published by Recorded Futures in April of 2022, last year, that a Chinese state-sponsored threat actor exploited an open source software called BOA, which BOA software is a small footprint web server embedded for embedded applications, which BOA's last software update was done in 2005. So even though this software has not been updated in 18 years, right, which is, should set off all of our cybersecurity red flags, the software is still available online today, and it's still being, and some of its web components are still being used through vulnerable software development kits. And so thus any legacy platform, such as BOA or anything else, they should represent a significant attack vector in critical infrastructure networks that all of us should be aware of. In February of 2022, Russian attackers targeted a misconfiguration in a VPN appliance that allowed for remote access to a trusted management network, which they used that trusted network access to gain access to a large number of managed CPE devices. And so I know Padma talked about managed CPE and unmanaged. So here they got access into managed CPE devices, in which here they were able to modify the configurations that resulted in internet access service or internet service disruption in and around Ukraine. And so in this case, the specific configuration changes that were made basically prevented remote restoration through the company. And so these KE-SAT modems had to be physically replaced through a ship and replace program, but all that did is extended the service outages because those configurations could not be restored remotely. And for the next one, here on the representative attacks, we talk about remote code execution. It's basically when an attacker accesses a computing device and makes changes remotely, similar to the one that I just talked about. But it's no matter where the device is located. So the RCE takes advantage of vulnerabilities in the implementation of a system component, such as overflow heaps and stacks to load and execute malicious code at runtime, and with privileges that allow them to take over system control. And so to minimize the threat of other attacks targeting this vulnerability, CISA and FBI and the Multi-State Information Sharing and Analysis Center produced a recommendation with several mitigation measures, which we highlight those in this report as well. And so next slide, please. All right, thank you. And so now we're going to start on the emerging threat vectors, which again I highlighted that the work group put together, which is kind of, based upon our the work group's vast amount of industry knowledge and experience. And these threat vectors are believed to have the highest negative impact on the CSP, the communication service providers, networks, and would likely be leveraged by threat actors. And so the first relates to machine learning and artificial intelligence. Both are used together to automate processes, optimize network performance, and improve the overall customer experience in a CSP's network. It enables network operators to reduce manual intervention, right? I mean, all of these networks are so large with potentially millions or hundreds of thousands to millions of network devices, and allows them to work with increased efficiency as well as improve security quality. Nevertheless, machine learning and AI is subject to certain cyber vulnerabilities, such as data poisoning, model stealing, adversarial attacks, and privacy violations. And then the next one on this one, number 3, or the second one, sorry, is deals with the threat vectors that relates to memory unsafe languages. Most of you probably know that the NSA released a software memory safety report in November of last year. The report highlights the risk associated with unsafe languages. Microsoft and Google both reported in 2019 and in 2021 that state that memory unsafe languages cause about 70% of all software vulnerabilities that require a software fix. And so our report goes into that a little deeper, plus it explores the specific threats also associated with spatial memory errors, temporal memory errors, and type confusion. Next slide, please, Karen. And then, so we'll continue on with a few more. So the other one is also inadequate zero trust implementations. So traditional management networks leverage a perimeter defense to keep the threat actors out of the network, which as a result kind of creates an implicit trust zone. The existence of these implicit trust zones opens up the managed networks to various attacks and allows for potentially easier lateral movement once that perimeter is compromised. The network operators, as well as the infrastructure vendors and the network management system vendors, sometimes the infrastructure and NMS vendors are the same, sometimes they're not. But they must work together to enable end-to-end adoption and implementation of zero trust principles. Ineffective zero trust implementation allows, for a threat actor, whether internal or external, to compromise a platform and move laterally with more ease. And so, if or when a supply chain security vulnerability is compromised, an effective zero trust implementation should help limit the depth of the attack, as well as allow the security operations teams to thwart the attack sooner in the kill chain. And then next, Padma talked about this one as well a little bit earlier on the hardware platform security, but on trusted platform modules. It's an international standard for a secure crypto processor that can function as a hardware root of trust. In 2019, just to give you a good example, a team of academics disclosed 2 vulnerabilities, which today are known as TPM fail. Both of these vulnerabilities have been fixed in the industry, but the work group collectively feels that this class of vulnerability presents an ongoing supply chain risk that again, the industry needs to be aware of. And on to the next one, the communication service providers at times can face challenges in selecting best of breed components. Providers may not always have the funds to routinely perform replacement of end-of-life equipment. When equipment reaches the date which the manufacturer has defined end-of-life, beyond that, no further software development from the vendor means there's no updates, there's no bug fixes, and more importantly, there's no security fixes that will be published for that equipment. And so just similar to what we talked about with the BOA server being, the last update was 18 years ago, we don't want to find anybody in that situation. And so 2 examples of this attack were also published, and the published vulnerability were reported in 2023, so this year. And the work group thoroughly reviewed the details of these in the report. And so essentially the continued operation of end-of-life infrastructure creates opportunities for a threat actor to exploit that infrastructure and to execute an attack against the CSP. And then on to the next one with consumer-grade network. Another means for cost control is to implement non-enterprise grade hardware within a CSP's network. Not saying all CSPs do this. This is just a topic that was brought up in the work group. But this can include consumer-grade network devices such as routers, cameras, and smart devices. The work group identified a number of threat vectors with consumer-grade infrastructure, including the some that may not be receiving software updates from a centralized network management system. They may not be, the consumer-grade hardware may not include vendor support for security fixes. And it also may have a shorter life cycle when compared to enterprise hardware, which means it could find itself in that end-of-life phase much sooner than not. And so, again, just something to be aware of. And then also, lastly, some providers may find themselves in a situation where they rely on unofficial channels for procurement out of necessity. So, at times, right, there's equipment supply chain delays that sometimes are out of our control, similar to what Padma mentioned on the first executive order on supply chains. It was more about raw materials and certain materials, including pharmaceuticals. not so much on supply chain security, but sometimes there could be delays in some of those raw materials that does create supply chain delays. There could be manufacturing mergers and dissolutions, and/or the need to obtain equipment more quickly. And in certain cases, this can result in CSP providers, both large and small, turning to secondhand markets to procure used hardware. And so this secondhand hardware comes with a number of security concerns, which the work group also identifies and discusses in the paper. So, next slide, Carrie. And so now that we've got, we've been through the analysis and the deep dives of the representative attacks and the emerging threat vectors, the work group did identify some key findings across these areas. And again, the recommended mitigations that are in the report are based upon these key findings as well. And so first, the continuing evolution of the disaggregated supply chain will continue to present new challenges that are not easy to solve. I think this is a very complicated topic and discussion, and so many irons in the fire and so many different parts and pieces of vendors that are providing and integrated and somehow tied to this supply chain is very complex. Supply chain attacks can be addressed by considering the prevention and detection of vulnerability insertions in the supply chain itself, and operational security capabilities should be implemented that are designed to mitigate the exploitations of those inserted vulnerabilities. So I think we wanted to at least come out and clarify that the supply chains are about the detection of the vulnerability insertions, and then operationally, what can we do to mitigate those exploitations of those inserted vulnerabilities, right? Two big key topics. And on to the next one. So the vulnerabilities and threats facing small providers is much the same as for large providers. I think Padma mentioned that as well earlier. And that also, a repeat of what Padma said, and I think it's important, the hardware relies on software, right? And so, you always have, typically, most of the time, have firmware and stuff within hardware. As well as network management as systems as a collection of software. And thus, these recommendations will be necessarily centered around software. Next slide, Karen. And so to go beyond that, just to let everybody know kind of collectively what we did find is from an industry perspective is that, there's already some great work that's been done in the industry that can better support operators both large and small. For instance, ATIS has their 5G network assured supply chain, which was published just last year, June of last year. TIA has their supply chain security specifications that was published in December of 2021. So again, very, very relevant for everybody. MITRE has developed their supply chain security through their system of trust framework, as well as a risk model manager application that assists with the developing of a risk score for vendor comparison. So, if there's somebody in cybersecurity or in engineering or procurement that wants to, compare multiple vendors together and see how they score against each other from a risk perspective, MITRE has that application that's free to use. For government activities, I think what we came back with is that information sharing across international boundaries is more critical for open source software vendors and/or developers who may have ties with unfriendly countries, right, and/or known threat actors. So again, establishing that communications across different entities, government agencies is really important, so we can better understand the provenance and everything coming from those, the software itself and the developers. Adoption of zero trust principles in not only the supply chain, but also in operational networks to limit the blast radius of the supply chain exploit is really important. H-bombs should include SBOMs, right? Just like we talked about, hardware includes software, so HBOMs should include SBOMs since essentially all hardware consists of software. And just like there's an inconsistent and lack of universally accepted standard for SBOMs, HBOMs are in the same boat, right? We need we need to have a universally defined understanding of what HBOMs are via standards to more effectively perform security analysis on them. Next slide, Corinne. And then we've also hit upon memory unsafe languages at the end. They're going to have to be phased out. I think NSA's report is pretty telling to that fact. But understandably, it's a significant challenge, right? You can't just come up and replace all of your code for your applications or your network function or your radio or what's in your UE device overnight. So it's going to take a lot of time to do that. And I think, but at the end, planning needs to be initiated sooner and small incremental steps need to be started. I think that would, again, you take one bite of the elephant at a time to consume the elephant. And this is definitely a big elephant on migrating from memory unsafe languages to memory safe languages. Machine learning and AI require additional review and industry collaboration to define proper security specifications and or best practice guidelines for the vendors and CSPs. Hardware, on the next one, from platform security, hardware must be delivered with effective platform security, and legacy platforms need to be upgraded to eliminate any persistent risk within the infrastructure and network management supply chains. Network management solutions should also support and use security controls that can detect if any received software artifacts, such as software builds and configuration files, have been tampered with. And that's not just for the NMS platform itself, but it's also for those devices, that infrastructure that network management is providing some oversight for. Next slide, please. And so now we get into our recommendations. And so the recommendations were centered around two key objectives. And so again, what we talked about was the prevention and detection of vulnerability insertions in the supply chain, and two, the operational security capabilities specifically designed to mitigate those exploitations of any inserted vulnerabilities. And so in the report, the work group identified 20 vulnerabilities and 38 mitigating recommendations using the work group's definitions for infrastructure and network management systems. Most of the vulnerabilities and mitigating recommendations are software focused, as we discussed. One of the key objectives for the mitigating recommendations for the work group was to really limit that potential damage by reducing the blast radius from a successful supply chain attack. And so these vulnerabilities and recommendations fall into several different domains, which are listed here. Again, these are also discussed in the report in the recommendations table that's at the end. So, next slide, please. And so the other recommendations that we make for the commission is that the work group generated these additional, recommendations, which all of these present several opportunities for the industry to coalesce and collaborate to strengthen the security capabilities within the network and compute infrastructure domains, as well as evolve the security operations and security automation with the delivered vendor products and network management systems. So referencing back to the national cyber strategy that was, the updated one in March of this year, these are really focused on secure by design and secure by default. And so the work group recommends an examination of the use of machine learning and artificial intelligence in a CSP environment, to study the security impacts of memory unsafe languages in a CSP environment, to assist the standardization of HBOM formats and use, facilitate a study to investigate the benefits and feasibility of standardizing 3GPP network function event logging. And then lastly, to explore the benefits and practicality of a runtime security capability within a 5G system, and a 5G system being the core network, the radio network, and of course the user devices. So with that, next slide. And so this concludes the summary of Work Group 5's second report. Padma and I both appreciate the opportunity to lead this work together and to share the summary slide deck with you all. With that, we'll be happy to take any questions.
And the floor for considerations and or questions for Work Group 5. Michael?
Thank you, Todd and Padma. Huge piece of work. I can't imagine how many hours the working group put into producing this. I have one question on the topic of government activities. This report is a recommendation to the FCC for what infrastructure and network management solutions providers should be doing. I think, at least that's in the preamble, something like that. Section 7.2, though, talks about government activities. And in there, it actually talks about mandates, mandating SBOMs and hardware bills of material. That shows up in a sentence fragment. The sentence fragment is, the ability to mandate and authenticate the provenance of software and hardware is critical, as well as mandating SBOMs and hardware bills of material, HBOMs, for example. I'm uncomfortable with a government mandate recommendation in this report. Is that really the intent, or is that, am I overreading this? And if it's not the intent, is it possible to get the sentence fragment struck before publishing the final report? That's section 7.2 on page 38.
Yes. No, I see it.
Yes.
Thank you for the question.
It's your
Mike,
report,
and
and
it's a
I'm
very
telling
good
you where
one.
to find it, yeah.
No worries. And Padma, please chime in where you like as well. And so there is some understanding that from the government perspective, some of what they have done for internal government procurements is that they have started mandating the SBOMs for government contracts. And so I think most of this is really talking more about what the government activities is doing more so than what they are mandating the industry to do. And so, I think some of our representatives from CISA had brought that up as well during the meeting, that they were in a phase where, through one of the executive orders, that they were being challenged to start mandating those SBOMs in all government engagements or procurements. Padma, is anything else you want to add?
No, you covered it. Thank you, Todd.
Okay, thank you
Does that
for
make sense,
for that.
Mike,
That
or do you think
clarifies.
we need more clarification?
Yeah, no, that does clarify, and I appreciate that. Since it's clear to this room, could we get it clarified in that paragraph? Maybe get the report approved for publication with a modification to that one line? Is that something you could consider? I mean, it's about government procurement, but this doesn't actually say government procurement.
Yeah.
Yeah, one of the things I
Understood.
struggle
have
with
no
is
issues
the
updating
lack
it.
of
For
maturity
me
of.
and Padma have no issues updating as long as Suzanne and Kurian and Nazreen and Billy Bob are okay with it.
Yes, that's acceptable. That's
Yeah,
part
if I could
the
just.
purpose of the discussion, yes.
Thank you. If I can just sort of justify why I'm being such a bear about this, and I apologize for disrupting, but the maturity, I just finished working as part of a working group for HBOMs on the ICT Supply Chain Risk Management Task Force under DHS. And we did a lot of looking at the topic, and while it's certainly a powerful tool, it's not very interoperable yet and needs some work, needs standardization exactly as your report points out. SBOM is further along and still needs additional maturity and experience in industry deployment. So And interoperability is something that you gain not by writing a standard, but by doing exchanges of documents over a period of years and gaining experience. So all of that suggests that while this is directionally correct, the immediate mandate language was what kind of triggered me and made my eyelids twitch. So anyway, thank you for that consideration.
Michael, what section was that? Can you repeat it?
7.2.
Thank you. Other comments or questions?
Yeah, I don't see it in the written slide reports that we have here, or notice it in the actual written report, but and perhaps I'm mistaken, but it seemed to me that in your presentation you mentioned open source, particularly as providing a broader attack surface. And I just wanted to ask, was there any distinction here made between the open source and proprietary software in the report or recommendations? I know the report mentions open source and defines it, but my glance through didn't seem like it was making any specific recommendations that were unique to open source or flagging any particular dangers with regard to open source as opposed to proprietary, and I just want to confirm if that's the case or not.
Sure. I think it's a good observation. In the first report we published in September of last year, we focused really on the software side, and so we did discuss more on the open source software in that report. We did not necessarily talk as much about open source software in this report, other than we really focus more on the provenance of that software. So, which again, we discussed that in the first report as well. So, so that might be some of the confusion, you think?
All right. So, but the issue of provenance, is there unique issues with regard to open source as opposed to proprietary, tracing back the necessary provenance? I mean, proprietary software draws on code libraries and other elements that could introduce potential vulnerabilities.
Yeah, I think here, you know, the recommendation was more about just establishing or improving international communications across boundaries for sharing and being able to collaborate somehow on that open source software, both from a developer side and a software the software source itself, because some of the authors of that code or entities that created that open source code could have ties back to unfriendly countries. And that's really all we were trying to highlight in this report, without getting too much more detail than we did in the first report. So again, just being able to understand, you know, the individual X or entity Y, you know, are they tied to unfriendly countries? Yes or no? Is it something we should be concerned with? Yes or no? And help us better understand that. Because again, so much of this hardware from an infrastructure network management systems, you know, it's such a complex ecosystem of various different entities, developers coming from across the globe, that makes it really tough. And I think just having that level of transparency at the CSP side is really important.
But again, just to clarify, the same concerns exist with regard to proprietary software as well as open source software with regard to this kind of provenance and ensuring that there isn't some trace back to a adversarial country that might deliberately introduce vulnerabilities.
No, I mean, absolutely. We don't want to trust necessarily any software, right? So it's kind of that there's no zero trust principle, right? But I think, you know, at least from proprietary software that's coming from, you know, recognized industry respected organizations, definitely carries a little bit more weight. And I don't want to say trust, but we still have to validate that at the end of the day. But it is also that open source. And of course, these vendors, they're developing infrastructure and developing products and services as well as network management systems that do include and embed free and open source software into it. So these vendors are delivering that side by side with their proprietary software. And so again, we have to look at everything very holistically, but at least from the proprietary software, we have a good sense from the vendor who it's coming from, right? We can understand they probably do a ton of background checks and we can work that out. But it's that open source software that sometimes comes unknown, that there's a little bit of mystique or stealthiness potentially about it. Maybe not all, but some that could be implanted into different repositories that could be, could create us significant challenges in the future.
Was there, in your research, was there specific evidence of anything like that?
I mean, not necessarily. I think there's some concerns potentially. I think if we look at certain supply chain attacks or whatnot, or software supply chain attacks, I mean, there's definitely instances where some of that was compromised. Even if we look at the Log4j that was maliciously updated, or I don't want to say maliciously, but it was updated in the sense that, it was doing stuff that it should not have been doing. Then I think that's areas where, we need to understand, where did that, who was the author that modified that? What was the provenance of it, right? Of the author, and was there any ties back to any unfriendly country? So I just think it's just being prudent and not necessarily calling out, and we didn't necessarily call out a specific incident or event, but I think as we look at that emerging threats and looking forward, that we just do the due diligence and just try to help, nip it in the bud, let's say, before. And that's why we put that, that kind of that recommendation that there should be more international communications across boundaries to help us better understand who's publishing and uploading this open source software on the open market.
Right, but again, and I just want to, the report highlights the growing complexity of the supply chain, and I just am hesitant to say that there is automatically more security with regard to all proprietary software. I mean, it may be true for some well-established vendors, but there are a heck of a lot of vendors out there, not all of whom are honest about their points of origin, and I just want to make sure that we apply equal caution with regard to both proprietary software and open source software.
Yes.
Yeah,
so one of the things,
and I think, let me add one more thing real quick, Pam. I think the only thing that we really called out in the first report on open software, open source software, is it less secure or more secure than proprietary? But it is pretty well proven through Synopsis's ongoing annual reports that open source software is not well managed within platforms, and so it doesn't go through the normal patching and bug fix programs that say proprietary software does, and that's really the only delta that we call out between the two. So go ahead, Pamela. Sorry.
Just one more thing I wanted to add to your, the point that the gentleman was raising is that, yes, true that traditionally open source software is seen as, since it's not gated as well as proprietary software, there might be more vulnerabilities, but there's also more eyes on it, right? So it could go both ways. And that's why if you look at our first report, we did conclude that while our report was very focused on supply chain and we identified open source proprietary source as one of the vulnerabilities that could potentially exist, we also recommended that there needs to be additional study that needs to be done where the focus is the open source aspect, the open source software aspect.
All right, Michael? No, you're good. Covered, very good. Anyone virtually has a question for Working Group 5? All right, so with the Section 7, with the agreement that Section 7.2 will be modified to, with reference to a specific language, to government entity as opposed to broadly industry as a whole, as Michael brought up, right?
Government procurement.
Government procurement.
Thank you.
I'd like to ask the group, for those in favor of this report, please say yay.
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 I will say yay, but want to emphasize again the discussion we just had with regard to distinctions between open source and proprietary code.
Thank you. Those not in favor of the report say nay. All right, the report is approved. Thank you. With that, yeah. Great job, everyone. With that, I'd like to pass it on to my co-chair, Billy Bob Brown, for closing comments.
Thank you, Nasrin, and thank you all for what has been a long road to get here to the end of this tremendous amount of work across CSRIC 8. I would like to, as we started at the very beginning, thank Bureau Chief Jordan and the Commission for their leadership in this effort. It's been a tremendous display of collegial, cooperative environment, and certainly for all the participants across the interagency and across all the various industry participants. You know, this is really what I believe it's all about. You know, that collaboration really, you know, as John talked about, you know, it's the importance of having a convener that can bring everyone to the table. And then as Padman talked about, is the cooperation of all the participants, you know, coming together to try to solve these national level challenges. And I really do believe that the Commission is setting a global example here, really, for how we try to think about cybersecurity, how we think about resilience for all of our communications infrastructures. And certainly, as we all know in this room, cyber does not have borders. And as we have seen, and certainly over the last 2 years of this work, there are demonstrations of challenges globally that I think challenge us all. So the work that you all have done has been tremendous. The research and the recommendations that I think is going to make the nation safer and more secure. So thank you to all of the great work that's been done, and thank you again for your leadership.
Thank you, Billy Bob. I want to express the Commission's thanks for the referrals of the reports today, for all 10 of the reports that you have referred to us over the course of CSRIC 8's charter. We really appreciate the tremendous amount of effort and expertise that went into this work. We certainly understand how much it takes to prepare and draft these reports, and I expect that the Commission will make every effort to use them and promote its mission in the most effective way possible. This is our final meeting, and I would like to add my thanks and deep appreciation to all of you for the work you have put in as members of CSRIC 8, as experts, as working group members, as co-chairs and liaisons, and to my deputy, Kurian Jacob, without whom none of this would have run smoothly. Thank you. Nasrin and Billy Bob, it's been a pleasure to have both of you serve as co-chairs, and we deeply appreciate it. Thank you all. And with that, I announce that the 8th meeting of CSRIC 8 is officially closed. Thank you all.
Thank you.
Thank you.